Hi friends, greeting to all. Myself SP Rajesh, Assistant Professor, the Department of Food Technology from Excel Engineering College. Today I am going to talk about refrigeration systems. Uh, what is the mechanism used for refrigeration process? The main mechanism is just to produce the low temperature of space or body of the systems when compared to its surroundings. This is the main mechanisms. Here, heat is generally pumped from lower level of concentration to higher level. Okay. Before that, before enter into the refrigeration system, just we are going to discuss about what is meant by refrigeration. Okay, the term refrigeration may be defined as the process of removing heat from a substance or space or body under its controlled conditions. I mean, under controlled temperature conditions. It also include the process of reducing heat and maintain the temperature of body below the its surrounding temperatures. In other words, the refrigeration means a continuous extraction of heat from a body whose temperature is already below the temperature of its surrounding. And the refrigerator and the refrigerant. The device which is used to carry out the refrigeration process that may be called as a refrigerator. The refrigerator is a reverse heat engine or heat pump which takes out heat from a cold body and delivers it to the hot body. Okay. Yeah, the refrigerant is a heat carrying medium. The medium may be fluid, air, or whatever liquid medium we can use. The refrigerant is a heat carrying medium which, during their cycle in the refrigeration system, absorb heat from a low temperature system and deliver it to a higher temperature systems. Okay. A refrigeration cycle. In refrigeration system, the heat is being generally pumped from low temperature side to higher temperature side. The absorption of heat from the refrigeration system that may be rejected to the higher concentration of the surrounding. This rejection of heat from the low level to higher level of the temperature can be performed with the help of external work according to the second law of thermodynamics. We need some mechanical work or external work. I mean, mechanical work need to extract the temperature from lower concentration side to higher concentration side. Here, the heat rejection also done at the higher concentration side of heat or temperatures. Okay. Heat rejection. The total amount of heat being rejected to the outside body consists of two parts: the heat extracted from the body to be cooled. When you are remove the temperature or absorb the temperature from the space or system or any body, that may be become cool. Okay, this is the first one. Second one, the heat equivalent to the mechanical work required for the extraction of heat or heat energy. So here, heat rejection equal to work done. What is the, I mean, equal amount of work should be applied to remove the heat amount from the space. Here I have shared the simple uh, diagram of a single stage vapor compression refrigeration system. Uh, Here we have used a fan as a mechanical device in order to produce the mechanical energy to remove the heat from the lower concentration side, that may be done at the evaporator side, and then the refrigerant move to compressor. Here a low pressure and low temperature refrigerant convert as a high temperature and high pressure vapor refrigerant. Then the refrigerant move into the condenser. Here condensation takes place. The condensation is nothing but cooling process. Here the phase change also may be occurs. The vapor phase of refrigerant may be converted as a liquid phase of refrigerant, then pass it to the expansion device. Here expansion takes place. Expansion is nothing but reduce the pressure and the temperature of the working medium. Here working medium may be refrigerant. The refrigerant you can use as a whether air or water or liquid phase or gaseous phase also based on the purpose. Then move into the evaporator. The cycle may be continued. A refrigerator is a reverse heat engine runs in the reverse direction by means of external air. I mean external mechanical work here. Every type of refrigeration system used for producing cold must have following four basic units. First one is refrigerator, low temperature thermal sink to which the heat is rejected for cooling the space. I mean, uh, what is the amount of heat is rejected from the refrigeration system or space that may be done at the evaporator side. Meaning of extracting the heat energy from the sink, rising its level of temperature before delivered into the heat receivers. I mean the surrounding side. The receiver is a storage to which heat is transferred from higher temperature and a high pressure refrigerant. That may be acting as a accumulator as a device just storing the refrigerant from the condenser and then pass it to the evaporator based on the requirement. Okay. The meaning of reducing the pressure and the temperature of the refrigerant before it turn into the sink. The process of cycle or evaporation, compression, condensation and expansion. All the process done by each devices. Yeah, we have two different refrigeration systems. One is vapor compression refrigeration system and vapor absorption refrigeration systems. Now we will discuss about vapor compression refrigeration system. This is the most important system from the point of commercial and domestic purpose. Most of the industry and practical purpose they are using vapor compression refrigeration systems. The working fluid refrigerant used in this refrigeration system rarely evaporate and condense or change the alternative between the vapor and the liquid phase without leaving the refrigerant plant. Okay. During the evaporation, the refrigerant absorb the heat from the cold body or in condensing or cooling in reject heat to the external hot body. Here external hot body may be a surroundings. Okay. The heat absorbed from cold body during the evaporation is used as its latent heat for the converting its liquid form to vapor form. Actually, we are passing uh, lower level or low temperature of liquid into the evaporator. Here, heat absorption takes place. Uh, a refrigerant after absorb the heat from the object that may be converted as a vapor. The absorption of heat may be as a latent heat, as the cooling effect is created in the working fluid. Okay. Here I have shared the vapor compression refrigeration system cycle. We will start from evaporator side. Here evaporation takes place. Uh, all the four devices are connected by the pipes or uh, lines to carrying the refrigerant. When you are the refrigerant enter into the evaporator, here evaporation takes place after latent heat from the evaporator side. That's why the device may be called as evaporator. Here evaporation done by the absorption of lateral heat from the space. So high temperature, low temperature and low pressure of refrigerant will comes out from the evaporator and enter into the compressor. Okay, again the refrigerant enter into the compressor. Here compression process may be done. Okay, compression is nothing but increase the pressure of the refrigerant and the temperature of the refrigerant also during compressions. Here simple compression, single stroke compression is sorry compression. Here we have attached. Okay, uh, after the compression, high temperature and high pressure of refrigerant comes out from the compressor and then pass it to the condenser. Here condenser is nothing but cooling process. Here high pressure and high temperature refrigerant may be cooled at the same time. The phase change occurs from vapor phase to liquid phase. The low temperature and low pressure of refrigerant may be stored in the accumulator. The accumulator may be acting as a receiver here. Okay. After stored in the receiver, that may be sent to the expansion device. The expansion device used to uh, pass the refrigerant to the evaporator side based on the requirement. What is in the evaporator, sorry, expansion side, expansion takes place, I mean, reduce the pressure and the temperature of the working medium. Working medium here, working medium is refrigerant. Okay. The four main components in the refrigerants are expansion device and the evaporator device and the compression and the condensation device. uh, this is the compressor. First, the low pressure and low temperature refrigerant from the evaporator is drawn into the compressor through the inlet and the suction mode, where it is compressed to high pressure and temperature. The high pressure and temperature vapor refrigerant is discharged into the condenser through the delivery or discharge valve. Okay. The condenser or cooler consists of coil or pipe in which the high pressure and temperature vapor refrigerant is cooled or condensed in the condenser itself. The refrigerant, while passing through the condenser, rejects its latent heat to the surrounding. Okay. As a hot refrigerant vapor received from the compressor is converted into the liquid form in the condenser itself. Okay. Then condensed liquid refrigerant from the condenser is stored in the vessels that may be called as receiver accumulator, where it is supplied to the expansion valve, the refrigerant control valve. Okay. Expansion valve. The function of this valve is to allow the liquid refrigerant under high pressure and temperature to pass at controlled rate after reducing its pressure and temperatures. Here, the temperature and pressure of the refrigerant may be decreased by the expansion process. Some of the liquid refrigerant evaporate as it's passed through the expansion valve, but greater portion is vaporized in the evaporator at the low pressure and temperature. Uh, I have listed some advantages of vapor compression refrigeration system. Small size for the given refrigerator capacity. At the same time, that has high coefficient of performance and compared to the heat effect and what is the heat energy supplied to the system. Lower power required for the given capacity. When you are getting high coefficient of performance, we should reduce the required input energy also. Okay. Here we have less complexity in both designing of equipments in all four components and operations also. It can be used over large temperature purpose also. Okay. Thank you.